Welcome to The Explainer. Today we're pulling back the digital curtain to look at the very fabric of our modern world. Whether you're using a smartphone, driving a car, or even just browsing the web, you are interacting with complex systems designed by software engineers. But what exactly goes into making these invisible engines run so smoothly? Well, in this explainer, we're going to demystify software engineering together. We'll look at the core principles, the life cycle of a product, and what it actually takes to build a career in this massive, ever-changing industry.
Okay, let's dive right into our roadmap for today. We're covering 1. What is software engineering? 2. Program versus software product. 3. Core engineering principles. 4. Attributes of great software. And 5. Careers, tasks, and skills.
All right, Section 1. What is software engineering? Moving beyond the hacker myth. When most of us think of coding, pop culture immediately hands us this image of a lone genius in a dark hoodie, frantically typing away, hacking into a mainframe in 30 seconds flat, right? Well, forget that trope. Real software engineering is actually defined as the systematic process of designing, developing, testing, and maintaining software using highly specialized techniques. The end goal here is high-quality, reliable, and cost-effective results. Think of it less like writing a quick email and much, much more like building a massive physical suspension bridge. Look, if you're building a bridge, you don't just show up with a pile of steel and a blowtorch and start winging it. No way! You need architectural blueprints, quality materials, strict budget management, and rigorous, absolutely uncompromising safety checks. Software engineering brings that exact same level of physical construction discipline straight into the digital world.
Moving on to Section 2, Program versus Software Product. The big distinction. So you might be wondering, what actually separates that fun little weekend coding project you did in a Python tutorial from a massive commercial application used by millions of people every day? Well, it really boils down to scope. A program is basically a solo sprint. It's just a set of instructions given to a computer to achieve a specific task, usually with minimal to no documentation, and writing it is just a single stage of work. A software product, on the other hand, that's an organized marathon. It is the program plus comprehensive documentation and licensing. It has a much broader scope meant to solve real-world problems, and crucially, it follows a full software development lifecycle. That means it requires feasibility studies, prototype development, system design, coding, and intense, rigorous testing.
And here's something kind of cool. Software also plays a fascinating dual role in the industry. First off, it can act as an end product. This is what we're most used to, right? An app on your phone that delivers computing potential, or acts as an information transformer, modifying or displaying data for you. But software also acts as a crucial vehicle. It provides underlying system functionality, like a payroll backend, or it controls other software, like an operating system. Sometimes software is literally built to help build other software. Think of developer tools and code editors. It's both the product you buy at the store and the factory equipment used to actually make it.
Section 3. Core engineering principles. The foundation of it all.
If software is a giant skyscraper, these principles are the underlying physics and architectural blueprints keeping it upright. First, there's how we actually structure the code itself. Modularity divides the software into small, independent parts that are way easier to develop. Abstraction shows only what's absolutely necessary to the user while hiding all those messy internal details. And encapsulation safely groups data and functions together, protecting them from outside interference. Then, there's how we manage the actual work process. Engineers use proven design patterns to repeatably solve common problems. They follow agile methodologies for flexible, step-by-step development with constant feedback. And they rely on continuous integration and deployment, or CI/CD pipelines, to automatically merge and launch code updates. And tying the whole shebang together, rigorous testing and maintenance to ensure the structure actually works and stays secure over time.
Section 4. Attributes of great software. The gold standard.
Okay, now that we know how it's built, what makes a software product truly great? What are the objectives that engineers fiercely strive for? Well, for the user, it really comes down to a seamless experience. Reliability ensures it simply doesn't crash when you need it most. Efficiency means it doesn't drain your device's memory or battery life. And adaptability and portability mean it runs smoothly whether you're on a laptop, a tablet, or adjusting to different network constraints. Oh, and let's not forget interoperability, which is exactly why your fitness app can seamlessly process data and share it right to your smartwatch. But flip it over to the engineer's side, and a great product needs correctness, meaning it perfectly matches the original requirements document, and high testability to easily evaluate its performance. Finally, for the future of the company, the code absolutely must have strong maintainability so it can evolve easily, and reusability, so those digital building blocks can just be grabbed and used in future products.
And lastly, Section 5, Careers, Tasks, and Skills, the human element. We've talked a lot about the code and the systems, but what does the day-to-day actually look like for the folks doing this for a living? This procedural loop breaks down the daily tasks of a software engineer, and it really drives home a crucial point. Notice that step 2, design and development, the actual coding part, is just one single step right in the middle of a much larger process. First, there's requirement analysis, where you're collaborating with stakeholders to figure out what actually needs to be built in the first place. After coding, you dive straight into rigorous testing and debugging. Step 4 is code review, where peers inspect your work to ensure quality and share knowledge. And finally, step 5 is maintenance and documentation. That's writing out API docs and fixing bugs so future developers can actually understand the system. It is a continuous, highly collaborative cycle.
Now, what's really interesting about this is the balance required to actually do this job effectively. Yes, for sure, you absolutely need heavy-hitting technical skills. Coding, software testing, object-oriented design, and a really deep understanding of the software development process. But look at this. Soft skills are given equal weight because, at the end of the day, software engineering is fundamentally a team sport. Your ability to be a team player, your creative problem solving, and your immense attention to detail are paramount. I mean, your ability to clearly communicate a highly complex idea to a non-technical stakeholder is just as crucial as your ability to write a flawless line of code. And listen, if you can master that blend of technical and soft skills, the industry just opens up a massive variety of well-paying job choices for you. You could be a general software engineer, or you could specialize. You could be a web developer, a quality assurance engineer testing for bugs, a cloud engineer managing distributed servers. You could focus purely on the user experience as a front-end developer, or the hidden database logic as a back-end developer. You could be a DevOps engineer smoothing out the deployment pipeline, or a security engineer literally keeping the hackers out. The professional possibilities here are practically endless, and they all depend on your specific interests and your industry.
So we've officially taken the mystery out of the matrix. We've seen that software engineering isn't just typing in a dark room. It is a systematic, highly collaborative, and deeply creative discipline that literally builds the infrastructure of our modern world. It requires a fine balance of strict engineering principles, crystal clear communication, and a drive to create reliable, adaptable products. The only question left is this. With all the different roles, technologies, and massive challenges out there, which software engineering path suits you? What piece of the future do you want to build? Thanks for joining me on this explainer. Keep learning, keep exploring, and I'll see you next time.